Okay, we're going to begin by looking in our Ready books. Today in our Ready books, we're on page 240. We have this beautiful line plot, and we're going to look at how to solve it. So the word problem reads, Juan drives a race car. The race car tracks vary in length. To prepare for the racing season, he recorded the lengths in miles of the track in the list below. Juan would like to see the distribution of the track lengths. Which line plot correctly shows the track data? So it lists me this data, and then it gives me 4 different line plots, and I understand that we can only see 3 right now, but it gives me 4 different line plots, and I'm supposed to figure out which one matches the data that's given. Now there are 2 strategies, and I'm going to tell you which one is the preferred better one, but I'm going to explain both to you. So the first one I could do is I could actually look at the line plots that are given and compare. Well, this line plot has the 1/4 mark, and it has 2 data points. So do I have 2 up here? Only 2 that say 1/4. So here's one that says 1/4. Here's one more. So there's 2. And that matches good. Let me continue on. This one has 1, 2, 3, 4, 5 at 1/2. Do I have 5 at 1/2? 1, 2, 3, 4, 5. Yes. And I could do that, continue on, and look at each one by one. So that is a strategy. If this one wasn't correct, then I would move on to my next one. 1/4, it has 1, 2, 3, 4, 5. There's 1, there's 1. I don't have 5 there, so that one clearly wouldn't work, and I would look at my next line plot. The reason I don't recommend that strategy is because while you can check to see does this match here, you might actually have a data point identified here that is not represented in the table. And although you can check these off on a piece of paper to make sure they work, when you're doing a computer-based test, you can't check these off to make sure you didn't accidentally have a data point here that's not represented at all on the table. So for me, the best strategy for you to do is to actually use this, create your data table using the data that's generated here, and compare your table against their table. However, I do understand that some people are going to count here and compare, but again, I could have a piece of data that's represented here that's not at all represented here, and you wouldn't necessarily notice that without having made your own table. So I'm going to go through making a table to represent that data, and then we can compare. So I have a scrap sheet of paper, and of course all you friends probably have your scrap sheet of paper as well. I'm going to look at that data, and I'm going to figure out what am I going to make my number line drawn in terms of. And I'm going to zoom in a little bit better so that you can see it. And I'm actually going to draw my line plot on the board so that you can see that as well. Now, hopefully when you're looking at this data, you will recognize what it should be drawn in terms of. When I'm looking at my denominators, I have 4, 2, and 8. And so my line plot should be drawn in terms of 8s because that 8 is going to be my equivalent fraction. I can make them all in terms of 8s. So I'm going to do a number line, and it's going to go from 0, and it actually needs to go all the way up to 1 1/4 because I do have that 1 1/4 represented there as well. So 0, and I'm going to put like my 1 mark there, and it can continue on for forever. And again, I decided that my intervals need to be done in terms of 8s because that would be my common denominator. So I'm going to draw in halves first. Then I'm going to take each half and cut it into fourths. I have 1/4. That would be 2/4. Here's my 3/4 and my 1/2. Take each fourth and cut it into halves, and now I have 1/8. This would be equivalent to 2/8. There's my 3/8. This would be 4/8. 5/8. This would be your 6/8. Your 7/8, and of course your 8/8 is 1/2. So now I've taken it and I've got 8s, I've got my halves, I've got my 4s, I've got it all there, and I can go through and plot it. Now of course I did draw my 1/4, but if I would not have actually labeled it as 1/4, maybe I would recognize that 1/4 is also equivalent to 2/8. So when I plot that on my number line, I'm going to plot at the 2/8. 1/2, again, what I do to go from halves to 8s, I multiply by 4. So this would be 4/8. This one's already in 8s, so I'm just going to trace over it so you can see it more clearly. 1/2, what did I do to go from halves to 8s? I multiplied by 4. So I need to multiply that numerator by 4 as well. 1 times 4 is 4. This one is in fourths, and again I need to go from fourths to eighths. What did I do to go from 4 to 8? I multiplied by 2. And again, 1 times 2 is 2. So I'm just going through and I'm creating those equivalent fractions. I have halves. What I do to go from halves to eighths? I multiply by 4. And again, what I do to the bottom, I must also do to the top. So multiplying that numerator by 4 as well. 1 times 4 is 4. This is just a whole number 1. Carry it down. I have 1 and 1/4. What I need to go from fourths to eighths, I multiply by 2. So what I do to the bottom, I must also do to the top. So multiplying your numerator by 2 as well. 2 eighths. Again, look at your next one. I have fourths. I need to get that common denominator of 8. What did I do to go from fourths to eighths? I multiplied by 2. So turning that into 6 eighths. And I'm going to want you to take a moment. I want you to continue to do that on your own. Maybe go ahead and pause the video now. Let everybody else finish creating those equivalent fractions with the common denominator of 8. Go ahead and pause. So hopefully when you went through that and you paused it and you completed it on your own, you should have gotten 1/2 is equivalent to 4 eighths. This is already in eighths. Going from halves to eighths is multiplying by 4, so 4 eighths. And your last one should have been 6 eighths. So I've created all equivalent fractions with the common denominator of 8, and now I can go through and generate my line plot. So 2 eighths, boom, cross it out, it's done. Do I have any other 2 eighths? I'll go ahead and do those now to save time. So there's one more, and that one is not 2 eighths, it's 1 and 2 eighths, so not that one. I should have 2 marks at the 2 eighths. Go on to the next one, 4 eighths. How many do you have at 4 eighths or 1/2? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, it's super important that I mark them off, because if I miss one, well then when I get to the end, they won't be marked off, and I know that, oh yeah, I forgot one. Let me go ahead and add that one in now. Okay, so 3 eighths. I have 1. No more. So 1 at my 3 eighths. My next one, so I've done the 2 eighths, 4 eighths, 3 eighths, 4 eighths, 2 eighths, 4 eighths. Oh, I got 1 at 1 whole. And I have 1 at 1 and 2 eighths. Now notice that when I drew my number line, I didn't draw anything there. I know now that I need to draw 2 more markers to get to the 2 eighths mark. So this would have been 1 8, 1 and 1 eighth, and 1 and 1/4, which is equivalent to 1 and 2 eighths. Marking it there. Go ahead and draw that on your number line if you haven't done so already. So I did represent my 1 and 1/4, or my 1 and 2 eighths. Go on to my 6 eighths. Again, it's 3/4 or 6 eighths. It's equivalent. And I have 2 of them. 1, 2. And then the last one that I'm going to mark, they're all marked off except for 7 eighths. And I have 1 of them at 7 eighths. So my line plot should look something like that. And now I'm going to take my line plot and compare it to the line plots that they've given me. Now, since I'm going to slide my book up, I'm going to erase this so that you're able to see the line plots that we're looking at to compare to. So, let me look at the very first line plot that they've given me. And I'm just going to slide my book right under there. So maybe I'll go over to the side. It'll be better. Looks like it's visually going to be easier. So, when I'm comparing my line plot to theirs, I see that at the 1 8th, I had nothing, and they don't have 1 8th, so they have nothing. At my 2 8ths, which is the same thing as 1/4, I have 2. They have 2. Look at my next one. 3 8ths. I have 1, and they have 1, which matches, but what I noticed is that I went from 1/4 to 3 8ths, and I got 1. But look at theirs. There's no space between mine. theirs, they have space between theirs. They have this 1/2 here. And I don't have my 1/2 here. I have my 1/2 after my 3/8. So what I noticed is that when they made their line plot, they don't have their intervals in order. What do I know about 1/2? If I were to take that 1/2 and turn it into eighths, 1/2 is actually equivalent to how many eighths? Right, 1/2 is equivalent to 4/8. I should not have 4/8 before 3/8. Look at 1/4. What do I know about 1/4? Right, 1/4 is equivalent to 2/8. So they actually have this line plot out of order. 2/8, 4/8, 3/8. They don't have the equivalent fractions in the correct order, so that even though the data might have the correct numbers, it's out of order, so that one is wrong altogether. So again, that's why I go back to you should construct your own. Because if I would have just strictly went by, I have this many data points here and this many data points here, I might not have noticed that the numbers are not in order. Okay, so clearly that first one doesn't work. Let's look at the one to the side of it. Right over to on the right side of that one. Looking at letter C. Now that I realize that they have made their line plots out of order, they haven't put the equivalent fractions right, I'm going to actually check that part first because that'll save me a lot of time in the long run. So 1/4 is equivalent to how many eighths? Right, 1/4 is equivalent to 2/8. Multiplying my numerator and my denominator both by 2. Here I have 3/8. 1/2 is equivalent to how many eighths? Right, 1/2 is equivalent to 4/8. And they have 5/8, so that one's good. 3/4, how many eighths? Good, 6/8. And they have 7/8, so that one's good. 8/8 is 1 whole. 1 1/8 is good. 1/4 is equivalent to how many eighths? Right, 1/4 is equivalent to 2/8. So just by looking at the number line without doing any of the actual comparison yet, do they have their number line created correctly? Right, they did it right. 2, 3, 4, 5, 6, 7, 8, 1, 2. So that piece is good. Now I can take their line plot and compare it to my line plot. So again, they didn't start at 1/8, they started at 2/8. They have 4 marks there, 5 marks there, and I only have 2. So right off the bat, I know that one's not going to work. I don't need to do anything with that one. I'm just going to move on. Let's look at the next one. Whoop, I guess I'm going out of order. So I went to A, C. Now I'm going to look at B. Whoopsie-doopsie. What happens? Look at that. I'm just going to line them up to see if they did that right. Nope. So when I lined it up to see if they still made it right, I have the 1/4 is equivalent to 2/8, and that one worked great. But this 1/2 doesn't work. 1/2 is not equivalent to 3/8. 1/2 is equivalent to 4/8. So they forgot to reflect the 3/8 there. So that one is not going to work as well. And I can see on my line plot that I do have something represented in my 3/8. They've completely left 3/8 out. So that one is not going to work either. So, oh, I'm just going to assume D works. Yes, let's circle D and move on. We're good to go. Oh, no? No, we're not. We still need to check it. Why is it that we would actually stop and actually check D and not just assume that D is going to work? Right, hopefully you'd realize that it is possible that you made an error somewhere else. So we never assume something's not going to work. We always actually check it and see, does it actually 100% for sure work? Because if it doesn't, well then I want to actually go back and see, did I make an error somewhere else? Is there actually one that I had thought didn't work that does work? So first I'm going to make sure is my number line lined up correct. Is it labeled correctly? 1/4 is equivalent to 2/8. Good. 3/8 is 3/8. Is 1/2 equivalent? And I'm going to line that up better. Is 1/2 equivalent to 4/8? Yes, it is. So that part works. 5/8 is good. Is 3/4 equivalent to 6/8? Right, yeah, I multiply my numerator and my denominator both by 2. That one's good. 7/8, 1, 1 1/8, 1 1/4 is 1 2/8. So perfect. They labeled it correctly, at least we're halfway there. But again, that does not mean I'm just going to assume perfect, we're good to go. I still need to actually take the time and work it out and make sure my points, my data points, are represented here correctly. So at my 1/4 or my 2/8, I have 2 data points. My 1/4, my 2/8, I have 2 data points. Good to go? Not sure yet. I still need to continue on. Then at my 3/8, how many data points do I have? Right, I have 1 data point. So I still need to go back. Do they have 1 data point? Yes. Okay, look at the next one. 1/2, 4/8. How many data points do I have? 1, 2, 3, 4, 5. Do I have 5? Yeah, so continue on. Don't just assume, all right, we're good to go, we've gotten this far, all right. No, let's continue on. So look at the next one that I represented was 3/4 or 6/8. So look at theirs. The 3/4 or 6/8. They have 2. How many do I have? Right, I have 2 as well. So does that part work? Yes, so let's look at the next one. 7/8. They have 1, do I have 1? Yes, so again, continue on. 1 whole. They have 1, do I have 1? Yes. The 1/8, they have none, do I have none? Yes. And the last one, 1 and 1/4 or 1 and 2/8, they have 1, do I have 1? Yes. So again, I stress the importance of actually taking the time and creating it. It did not take me more than a minute to create that line plot, and even if it took me 5 minutes, is it worth it if I get it right? Yeah. It's going to take time, absolutely, but it's nothing that I cannot do. So taking the time to create that line plot and then compare is going to be the most helpful. Again, making sure that you've created common denominators, that their fractions are in the correct order, and then that your numbers are actually lining up exactly, fraction to fraction, in the correct order. So now we've determined which one works correctly, which was D. Now we're going to take that information from our line plots, and I'm going to answer my questions. Now, one thing that I want to stress when we're looking at this is if you actually took the time and drew it, these questions are so much easier to answer because you have a quick 100% reference. I'm not accidentally looking at the wrong line plot. I have the correctly drawn line plot right out in front of me. So let's look at the first question. The first one says, look at the data in problem 1. Choose true or false for each statement. And if you remember back when we took the iReady test for this, it's like a select all. It's either you got them all right or you have none of them right. And I'm going to slide this down so you can better see that line plot. And hopefully you can see that on the screen. It looks good enough to me. Alright, other than the fact that I just moved the book. Alright, so looking at my actually drawn line plot and comparing it to the questions. The first one says most of the tracks are more than 1 mile long. Okay, well let's look at the line plot. Here's my 1 mile mark. And it says most of them are more than, which means greater. Are most of them more than 1 mile? No. So letter A is false. Look at letter B. Let's read letter B. The most common track length is 1/4 mile. So common means it has the most amount of data points. It's the most frequent. Do most of the people run 1/4 of a mile? Well, here is my 1/4 of a mile, again, equivalent to 2/8. And no, most people don't run that. I have 2 there. What distance do most people run? What is the most common track length? Right, it's that 1/2 mile, or that 4/8 of a mile, because it has 5 data points. So, again, letter B is false. Look at letter C. None of the tracks are 5/8 mile long. Let me take a moment and look at that line plot. None of them are 5/8 mile long. Is that true or false? Right, it's true. When I look at my line plot, I'm at the 5/8. Do I see any there? No. So is my statement correct? None of them are? Good, my statement is correct. None of them are 5/8 miles long since I have nothing representing the 5/8. None of them. Statement C is true. Look at statement D. The longest track is 5 times as long as the shortest track. So again, it's a comparison. I'm comparing my longest track is 5 times as long as the shortest track. So it's a comparison statement, and we've looked at those a lot with our fractions. What is my longest track? Okay, longest, short, longest. My longest is 1 1/4 or 1 2/8. I'm going to use that 1 2/8 equivalent because it makes it much easier to track. So 1 2/8 is 5 times as long as, so 5 times as long as tells me to do what operation? Right, times as long as is telling me to multiply. So 5 times as long as the shortest track. Well, what is the shortest track? Good. When I'm going across, I should achieve my shortest track is that 2/8. And again, I'm choosing to use that one because it has that common denominator for an easy comparison. So 2/8. And now I should notice that I've sort of created an expression. I have 1 2/8. I don't really have any kind of a symbol here, so I'm probably going to need to plug in a symbol to separate those two numbers. 5 times 2/8. So what symbol is missing? What symbol needs to go in? The word is represents a symbol. It represents something. Is represents equals. And we say that all the time. Like I could say 5 times 10 is 50. So it's telling me to equal. 6 times 3 is 18. So again, is telling me to equals. So I need to figure out, does 5 times 2/8 equal 1 2/8? It's a simple operation. You're multiplying a whole number by a fraction. How do I multiply a whole number by a fraction? Right, it's that whole number times your numerator. So 5 times 2 is 10. And your denominator? Right, it stays the same. So I need to figure out, does 1 2/8, does 1 2/8 equal 10/8? Take a moment and see. What do you notice about 10/8? Right, it's a fraction greater than 1. It can be regrouped to make a whole. So how many times can 8 go into 10? Right, 8 can go into 10 one time. And when I have that 8 go into 10 one time, how many am I taking away? Right, 8/8. I'm taking away 8 because 8/8 is giving me that one whole. How much would I have left then? Right, I would have 2 left, and you can see that they have 2 left. So is the statement true? Is the longest track 5 times as long as the shortest track? And again, the answer is true. Because when I found the longest track, and I wanted to see is it, meaning does it equal 5 times as much as the shortest, I multiplied that whole number times my numerator, and the denominator stayed the same, and I realized that 10/8 is equal to 1 2/8. So again, letter D is true. Okay, let's take a moment, go ahead and look at the next page. On the next page, we're given a new line plot, so I'm gonna, we still have a couple more questions. It says, look at the data in problem 1. And again, in problem 1 is where I had to figure out which line plot was correct. And so I still have my correct line plot. I'm going to use that one to answer this question. Look at the data in problem 1. What is the total length of all the tracks that are longer than 5/8 miles? Okay, so I want to figure out the ones that are longer than 5/8 miles. So first of all, when I look at 5/8 miles, I can see that there's no data points represented there. However, if there was a data point represented at 5/8, would I use that data point? No, I would not. But why not? Why would I not use it? Again, the question saying, look back at the data in problem 1. What is the total length of all tracks that are longer than 5/8? if there was a data point at 5/8, why would I not have included it? Good. The reason I would not have included it is because I don't want 5/8 and longer. I want the ones that are longer than 5/8. So anything from beyond the 5/8. So I need to find out, again, the total length of everything that's greater than the 5/8. So again, I'm going to use those common denominators of 8s, those equivalent fractions, to help me add, because I know that when I'm adding and subtracting, I must have a common denominator. So I have 6/8. And how many data points do I have represented at 6/8? Right, I have 2. So in groupings, I'm going to do 6/8 times 2. Now I recognize that you could do a repeat addition and do 6/8 plus 6/8. However, sometimes you might have like 5 data points like here, and you would not want to do repeat addition 5 times. So it's a lot easier, especially since this is a whole number, to just multiply it out. Well, your next one, you have 7/8, and there's only 1 data point, so I don't need to multiply that. What's the next number that I have represented? Right, I have 1 whole, so plus 1 whole, plus, what's the next number? Right, the next number is 1 and 2/8, and again, there's 1, so I don't need to multiply it either. Now I'm just going to check and make sure that I have all my points represented. So after my 5/8, I had 1, 2, 3, 4, 5. And when I'm looking, I had 6/8 2 times, and then 3, 4, 5. So all 5 data points are represented in my one expression. And now I'm going to go through one piece at a time. So the very first thing, GEMDAS is telling me that I need to do what part first? Right, I need to do those groupings, and even if I didn't use the groupings, I would know to do this first because what operation am I doing? Right, I'm multiplying, and I know that multiplication comes before addition. So how do I multiply a fraction? By a whole number. Right, I need to do the whole number times my numerator, which is 12, and my denominator stays the same. So 12/8. Now go across, drop everything down to create that equivalent expression, and you remember from a past test that at some point they did ask you with order of operations to create an equivalent expression. That just means one step at a time I'm dropping every part down. So plus 7/8 plus 1 whole plus 1 and 2/8. So now I have common denominators. I have finished with my multiplication. What is going to be my next step? Right, I'm now just going to go across. I'm going to add those fractions. How do I add fractions? I'm adding what? Right, I'm adding that numerator. So I'm adding 12, 7, and 2. You can line them up, going up and down, going vertically if you need to. But in this instance, they're pretty easy numbers. So 12 plus 7 is? Right, 12 plus 7 is 19. Plus 2 more is 21. And my denominator is 8. Because again, my denominator stays the same. But now I also need to include my whole numbers. So I have 1 and 1, which clearly is 2. So what do you notice about this fraction? 2 and 21/8. Right, hopefully you recognize that it is a fraction greater than 1, and I cannot have that with the mixed number with that whole number of 2 there. So I need to regroup. I need to regroup to make another whole. How many times can 8 go into 21? Oh no, 3 is too high. Not 3, because 3 times 8 is what? 24. So not 3 times. How many times? Good. I can do 2 times. I can make 2 more whole. So when I'm making those 2 more whole, 2 times 8 means I took how many away? Right, I took away 16 or 16/8. But I just know that my denominator is going to stay the same, so you don't necessarily need to represent it. So now how many whole do I have? I have 4 whole. And look at my numerators. 21 minus the 16/8 that I had regrouped. 21 minus 16 is what? Right, it's 5. And my denominator stays the same. So the total length for all tracks that are greater than the 5/8 miles is 4 5/8. Okay, let's look at the next question. And I think the next one is asking us to use this one. Sarah owns Sears Hardware. She made a line plot to compare the fuel capacity. Yeah, talking about that. Nothing to do with our tracks. So there goes that. I'm done with that one. I'm going to use their line plots for the next one. So, just in case you're wondering, there it is. That's Miss Foreman's snack. When I finish here, it's like a reward. It's like, all right, we're done with math here. How about have some barbecue chips? And you know what? Why not a blow pop? Because I'm definitely going to have some sugar cravings after this. All right, anyways. So Sarah owns Sears Hardware. She made the line plot below to compare the fuel capacity of several types of yard trimmers. So here it is. And again, you have part A, part B. Usually the answer to part B is dependent upon the correct answer in part A. Part A says, what is the most common fuel capacity of the trimmers Sarah sells? Someone's asking for the most common. Most common is telling me that I need to look for what? Right, the most common is telling me that I need to look and see which one has the most data points, which one has the highest frequency. And in this case, which one do you notice? Right, hopefully you notice the 1 and 5/8. It has 4, whereas we have 1, 1, 3, and 2. So for part A, your answer is 1 and 5/8. Okay, so let's use that information. Let's look down at part B. Part B says, the tanks of all of Sears yard trimmers are empty. How much fuel does Sarah need to fill the tanks of all the trimmers? So that one seems like a lot going on to it, only it's really not. So I'm going to read it again. I want you to pay attention to what it's actually saying, and then I want you to think, how would I solve this? What operation or expression would I need to do to solve this? The tanks of all of Sarah's yard trimmers are empty. How much fuel does Sarah need to fill the tanks of all the trimmers? So I'm going to reverse back to the line plot. Okay, so these are the tank capacities of all of her trimmers. And in fact, they're all empty. So in order for us to fill them all, I'm going to need to add up how much all of them can hold. So again, it's one giant expression. You certainly are probably going to need all the room they give you in order to solve it. So what I'm going to do first is I'm going to come up with an expression, and then I'll slide the book to actually go through the steps of solving it. So I'm going to first have those common denominators. I'll skip common denominators just in case you don't remember to do that. I'll come back to that piece. So first I'm actually just going to figure out the values of all of them. So I have 1 and 1/2. And there's only 1 there, so I don't need to do any multiplication with it. Plus 1 and 5/8 times 4. Again, there's 4 data points. I'm going to put that in groupings, but obviously order of operations would tell me that I'm going to be multiplying before I would start to join those together. Plus 1 and 7/8. Again, make sure you're getting this all written on your paper. Shame if you're not. You know what? We should rewind that and do that again. Ready? Shame if you're not. Okay, anyways. So 1 and 7/8. Then I have 2 and 1/8. Times what? Right, 2 and 1/8 times 3, because she has 3 tanks that have that capacity. And again, I'm going to use my groupings to help that stand out for me. And then the last amount she has is 2 and 1/2 times 2. So plus 2 and 1/2 times 2. Okay, so now that I have that expression, I'm going to go through and solve it. And again, I'm going to get my screen to a blank spot so that you can easily see. There we go. That's hopefully what your book looks like down below as well. So here I don't have anything to multiply. So again, I'm just going to drop it down to create that equivalent expression. 1 and 1/2 plus. Okay, take a moment. Think back. How do I multiply a mixed number? By a whole number. Think back to when we did that with conversions. With conversions, we sometimes had a mixed number that we had to multiply by a given unit. Right, you're supposed to multiply your whole number times your whole number. So 1 times 4 is 4. But we can't leave out that fraction, so what are we supposed to do with that fraction? Right, your whole number by your fraction part as well. So 4 times 5/8. Again, whole number times my numerator. My denominator stays the same. Okay, again, there's nothing to multiply here, so I'm just going to drop it down. 1 7/8 plus, again, mixed number times a whole number. How do I multiply the mixed number times a whole number? Right, whole number times my whole number. Whole number times my fraction. So 3 times 1/8 is 3/8. And then again, whole number times my whole number times my fraction gives me 4 2/2. Okay, so now I have this equivalent expression created. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. So just making sure I didn't leave anything off. It's easy to happen, but it took me like 3 seconds to do that quick check. Okay, so now what do I notice? Well, hopefully I notice that I can't add these up the way they are because I actually have an unlike denominator. So I need to figure out, well, what can I do to take 1/2 and turn it into my common denominator, which was 8. What can I do to turn 1 1/2 into 8? And I should hopefully recognize that 1 1/2 is equivalent to 1 4/8. So 1 4/8 plus, this is already in 8, so I'm just going to drop it down. This is in 8, so I'm just going to drop it down. This is in 8, so drop it down. And the last one, what do I know about 2/2? Right, 2/2 is equivalent to 1 whole. So 4 plus 1 means I actually have 5 whole. Okay, so again, I need to add these up. They have that common denominator now. So now I can add them up. How do I add fractions? No, you don't add your whole number first. No. Why do we not add our whole number first? Right, I want to look at the digit with the least value just like I would if I was adding and subtracting with decimals or even with whole numbers. We always look at the least digit first, which should in this case be our fractions because fractions are generally less than 1. So I have 4, 20, 7, and 3. I can rewrite them going vertically if I need to, making sure that my place value lines up. I can go one at a time, working left to right. But I know also that when I add, it doesn't matter the order of my add-ins. So I'm going to actually do 7 and 3, which is 10. So I chose that one because I knew it would give me a nice round number. 10 plus 20 more means I have 30. Plus 4 more is, right, 34. So you see, again, it doesn't matter the order that I add them in. I just chose what was friendliest for me. My denominator stays the same. And now I'm going to go through and look at my whole numbers. 1 plus 4 is 5. Oh, plus 5 more is 10. Plus 6 is 16. Plus 1 more is 17. So now it does not matter the order. Again, I could add them in another order. 4 plus 1 is 5. Plus 1 is 6. Plus 6 is 5 plus 6 is 12. 12 plus 5 more gives you that 17. So it does not matter the order you add them in. You're going to get the same numbers. So what do you recognize about 17 and 34/8? Right, again, it's a fraction greater than 1. So how many times can 8 go into 34? It's just like division. Again, think of that as division. 34 divided by 8. How many times can 8 go into 34? Take a moment. Right, 8 can go into 34 4 times. So plus 4 more whole. And 4 times 8 means you should have taken away 32. So when I did that, I took those 4, I regrouped it. How many whole do I have now? Right, I should have 21 whole. And what do I have left over? Good, you have 2 8s. What do I know about 21 and 2 8s? It's equivalent to what? Right, 21 and 2/8 is equivalent to 21 and 1/4. So the total amount of gasoline that she needs in order to fill all of her tanks is 21 and 1/4 gallon. Again, some extensions that you could do is you could find the difference between the least amount she needs and the greatest amount she needs. I know that when I'm subtracting, I want to have the larger number go first. I could find the average by taking that total of 21 and 1/4 and dividing it by the number of data points to assume I wanted to redistribute. There's one other skill that I'm going to just kind of hit on, which is not in your book, but it is a skill that we noticed when we did take our iReady assessment. So I'm going to erase this, and I'm going to go back, and I'm going to say, all right, let's say that she takes the gasoline from her 4 largest tanks. So look at your data. Her 4 largest tanks. So I'm going to slide this way. Okay, well these 2 are her 2 largest, which is 2.5 times 2. That takes care of 2 of them. And I want her 4 largest, so what is the next 2 going to be? Nothing there, nothing there. Oh, 2 more here. So those 2, again, these are all the same large, they're all the same capacity, so I can just take 2 from there, and I'm going to have now 2 and 1/8 times 2. So does everybody see where I got my 4 largest from? 2 from here, and then 2 from here. When I multiply that out, I'm going to get whole number times my whole number times my fraction, again, whole number times my whole number times my fraction. Okay, so that's what I'm going to get so far. And I know that 2 over 2 is equivalent to 1 whole, pretty simple. And join those together, I now have 5 plus, what do I know about 2/8 is equivalent to 1/4. And so now I can join them together, I have 9 and 1/4. So comes the question. Let's assume that she wants to redistribute that gasoline equally among 3 tanks. So I took my 4 heaviest, but now I'm actually going to divide it by 3 tanks. So it's going to be the same kind of a concept. I'm going to divide by 3 though. She wants to redistribute equally among 3. She takes her 4 greatest and redistributes it equally among 3, so dividing by 3. Same concept as any other time when I'm dividing by a fraction, I can actually do what? Right, I can do keep, change, flip, or multiply by its reciprocal. So 9 and 1/4. Keep, change. What is the reciprocal of 3 whole? It is 1/3. So I can redo this. Now how do I multiply a mixed number times a mixed number? Some of our friends have favored the good old-fashioned area model and done 9 and 1/4 times 1/3. And I know when I do that, I'm going to do 9 times 1/3, which is 9/3. And then 1/4 times 1/3, which is 1/12. I know that 9 divided by 3 is 3 whole, plus 1/12, 3 and 1/12. If I didn't do it that way, I could also turn it into an improper multiply, or my fraction times my whole, which would have been, same thing, 9/3, and then my fraction times my fraction, which would have been 1/12. Join together those 2 partial products, you would have still got the exact same answer. However you do it, your answer is going to be the same. But again, what I just did is I found the four greatest capacities, got my total of those, and then I redistributed equally among 3 tanks. So redistributing means I'm dividing it. So when I divided it, I ended up getting 3 and 1/12 for the redistribution. So that is it. Miss Foreman is tired. And also, let's not forget that Miss Foreman is hungry. A little bit of barbecue chips in there. Oh, yeah, look at those. Look at all that. Look at all that barbecue dust on there. And when Miss Foreman's done with that, then Miss Foreman is going to have this delicious This delicious blow pop, and I'm not going to say who this actually belongs to because it doesn't belong to me, but in fact it belongs to my belly right now. Have a good day. Test tomorrow for everybody in Line Plots.